Okay, let's look at some of the homework problems. I picked number 2 in 14.4. In 14.4, it says the figure shows the path of the particle that moves with position r. Draw a vector that represents the average velocity over the interval 2 to 2.4. So before I draw it, I want to figure it out. The average velocity between those two times will be this. Okay, and then between 2.4, 2 to 2.4, and this is from 1.5 to 2. Okay, so let me try to draw this picture. Okay, the difference between r of 2 and r of 2.4 is really small. Okay, so I'm going to say this is approximately 2.8. And we're going to say this is approximately 2.7. If you look at the units, the average between those two is 2.75. So when I draw it, this vector right here is r of 2.4 minus r of 2. And that's a little bit more than one unit. If you look on the thing, let's see, we'll say that's about 1.1. And then we'll say this one is about 1.3 because it's a little longer. And now we have to draw a velocity vector. So that's going to be about twice as long. So the velocity, let me draw it in blue. That's going to be right here, the first one. And the second one, let's say, is right here. And v of 2, is the limit as h goes to 0 of r of 2 plus h minus r of 2 over h. And the magnitude of that is the speed at t equal 2. And we're going to say that's about 2.75. So we'll do that in green. That's going to be about v of 2. Okay, so it's just kind of, we're just estimating um, these things and what they look like. So you don't have to get it exact. They just want you to see what these pictures look like, or what these vectors look like. Okay, number 4, velocity, acceleration, and speed, and we want to sketch it. So r is 2 minus t 4 square root of t. T equals 1. The velocity is r prime. That's minus 1 2 over the square root of t. I just take the derivative. V of 1 then is negative 1 2. Acceleration is the second derivative. That's going to be 0, negative t to the negative 3 halves. And a of 1 is 0, negative 1. The speed is the magnitude of the velocity, and that's the square root of 1 plus 4 over t. Okay, now to draw these, let's say r of 1, the position vector is going to be 1, 4. So v is negative 1, 2. So v looks like that. We'll put that right there. This is r. And then a is 0, negative 1. So a just goes just like that, straight down. Acceleration is straight down. Let me erase this out. I just made that the position vector. So draw the velocity and acceleration vectors and draw the path of the particle. Okay, so to sketch this, I'm just going to stall. Okay, so we have a square root, and let me just sketch this on the calculator. And it's going to go the opposite direction. The path of this goes okay, at t equals 0, the point's going to be 2, 0. And let me do that in green. It's going to go like that. So I just got that by eliminating t. Okay. Let's try 16. In 16, it asks us to find the velocity and position vectors that has the given acceleration and given initial velocity and position. So here we're going to have to integrate because we're going backwards. So velocity is the integral of acceleration. But v of 0 is 0 plus c, but that's given to be the vector 1, 1, negative 1. So we're just going to replace that in here, and v is the vector 1, 1, negative 1 minus 10t. And then r is going to be the integral velocity vector, and that's going to be t minus 5t squared plus, let's call it c1, another constant. R of 0 is 2, 3, 0, which is 0, 0, 0 plus c1. So c1 is 2, 3, 0. So r of t is t plus 2, t plus 3, minus t minus 5t squared. I'm just substituting that in for the c1. So there's my position, and here's my velocity vector. Okay, and the last one, let's try, is 32. I want to find A, T, and A, N. R is 1 plus T, T squared minus 2T. So R prime is 1, 2T minus 2, and R double prime is 0, 2. The magnitude of R prime is square root of 1 plus 4t squared plus 4 minus 8t. So remember, AT is, okay, so remember that A of t is r prime dotted with r double prime over the magnitude of r prime. So we have 1, 2, t minus 2 dotted with 0, 2. And that's going to be 4t minus 1 over the square root of 4t squared minus 8t plus 5. And then an is the magnitude of r prime cross r double prime over the magnitude of r prime. We can do that up here. If you do all the work, that's going to be 2k. So the magnitude of 2k is 2, and that's over the square root of 4t squared minus 8t plus 5. Okay, so it's just a matter of using those formulas to get your answer. Okay, well, I hope this helped, and when you work your problems in the homework.